Good morning, guys. Welcome back to Fecam's unique histology review series. This video is brought to you by the academic and editorial boards of the Federation of Catholic Medical and Dental Students, Fecam's unique chapter. Please do not forget to like our videos and subscribe to our channel, as this will encourage us to make more educational content. Thank you. So today we'll be discussing the histology of the endocrine organs. I will be looking at the thyroid gland, the pituitary gland, the pineal gland, and the adrenals. So the first one, which is the thyroid gland, let's read the side note. The follicles are lined by simple cuboidal epithelium. So that's one of the reasons for identifying the thyroid gland. And also there is presence of colloid in the follicular lumen. Then the development is from the thyroglossal duct. The function is production, storage, and secretion of thyroid hormones, T3 and T4. Regulators include the thyrotropin releasing hormone from the hypothalamus, and also the thyrotropin, which is released from the pituitary gland. The thyrotropin is also called thyroid stimulating hormone. So the lookalike gland is the mammary gland, and then the pathology is the goiter. So now, what are we expecting to see from the histology of the thyroid gland? The first and the most striking thing about the histology of the thyroid gland is the follicles. These round circular spaces. So they have varying sizes. One striking thing about the thyroid gland is that the size of the follicle determines the activity of the gland. So you have different follicles of varying sizes. Then the cells lining the follicles will vary in shape depending on the activity of the gland as well. So if the gland is very active, you find more columnar cells with less colloid. So if the cells are moderately active, if the follicles are moderately active, you find more simple cuboidal cells, and then a fair amount of colloid. So the colloid is this pink staining or this eosinophilic material within the follicles. So this pink staining eosinophilic material within the follicles represents the colloid. So if the follicles is moderately active, you see a fair amount of colloid. But then if the follicles are inactive, the cells will appear more flat, and then you see abundant amounts of colloid. One of the major constituents of this colloid is the thyroglobulin. So that's it. Then in between the follicles, you find connective tissue, and also you find parafollicular cells, or the C cells. And these parafollicular cells, which are between the follicles, secretes the hormone called calcitonin. So this calcitonin regulates calcium metabolism. So it reduces the amount of calcium ions in the blood. You can also find blood vessels within the connective tissue, within the stroma. So this is the follicles. So they are very distinct. They kind of look like the mammary gland that we discussed previously. But then in the mammary gland, if you look at the individual alveoli, you see fat droplets. Remember the description in the previous videos. So look at this. That's a classic mammary gland. Kind of looks like the thyroid, but then the follicles in the thyroid are much more numerous than this, and then they are much larger than this. Look at this. If you zoom in, this is the mammary gland. You can appreciate the fat droplets within the eosinophilic material that is in the lumen. You can appreciate fat droplets. This whitey species is the mammary gland. You can appreciate that. Some of the white species within the proteinaceous material, within the eosinophilic material. Same thing here. Here you can find fat cells within the connective tissue of the mammary gland, but then no fat cells in the connective tissue of the thyroid. So look at this. And then the mammary gland is arranged into lobes. And look at the duct of the mammary gland. You can't find the duct system in the thyroid. So look at the eosinophilic material within the duct. Notice the fat droplets. These circular, small circular white spaces within the fat droplet, within the eosinophilic material. Then you can see the clear lobular arrangement of the mammary gland. So this another section of the mammary gland. You can see the fat droplets within the eosinophilic material. See the fat droplets, these white spaces, these pale staining areas. So see that. If it were the thyroid gland, you will see more uniform eosinophilic materials. See the way this one is uniformly stained. And then you can also see the clear connective tissue and then the parafollicular cells in between. So look at this one too. You can appreciate the parafollicular cells and then the colloids and the follicles with their cells. So this is more like an inactive thyroid gland because the cells appear flatter and then with full colloid, with full eosinophilic material, which is the colloid. Same thing here. You can see numerous follicles, and then you can't find fat cells in the connective tissue holding the thyroid gland together. You can't find fat cells as in the mammary gland. So you can appreciate the colloids, this pink staining eosinophilic material, and then the follicles. They are numerous and they have varying sizes. So the thyroid gland is classical. Nothing comes close. So you shouldn't mistake another gland or another organ to be the thyroid gland. So while the thyroid follicles produce the thyroid hormones, the chief cells of the parathyroid produces parathormone, which play key roles in calcium metabolism. So this is like an image of the thyroid gland shown together with the parathyroid gland, because in gross anatomy, in normal human anatomy, the parathyroid gland are in close proximity. They are embedded within the thyroid gland. So the parathyroid gland is in close proximity with the thyroid gland. So look at this structure that contains numerous cells packed together, suspended within the thyroid gland. See this? So this is the thyroid, and it contains the features we've explained before: the colloids, and then the follicles and parafollicular cells. See that? The follicles. Then the parathyroid gland. So the cells in the parathyroid gland are much more packed together. And then you can find few fat cells in the parathyroid gland, though they are not visible here. Okay, so see this one too. Here they are comparing the slides of the thyroid and the mammary gland. So notice the homogeneous colloid in the thyroid follicle. So notice how uniformly staining these follicles appear. And then in between them, the parafollicular cells or the C cells. Now look at the mammary gland, the alveoli of the mammary gland. I've described this before. Look at the fat droplets in most of the alveoli. And then if you look at the connective tissue in between the lobules, you can find clear white spaces, which represents the clear white circular spaces, which represents the fat cells. See that? They are numerous. So you can't mistake this for the thyroid. See that? They are numerous. Okay, so that's it for the thyroid. So the next organ that we are going to look at is the pituitary gland. So let's read the side notes. In this slide, you have a gland divided into two main parts. The darker part represents the anterior pituitary with many cell types producing many hormones. The lighter part is the posterior pituitary that stores hypothalamic hormones. In between the two is the pars intermedia that doesn't peak stain. It stains poorly most of the time, and it is rudimentary. It is rudimentary in humans. So the reasons for identifying the pituitary gland, the anterior pituitary gland, is mainly the presence of chromophobes and chromophales within the pars, the anterior pituitary. Then the development of the anterior pituitary gland is from the rat case pouch or the hypophyseal pouch. The location is the cellular tussica. Then the production functions include the production, storage of hypothalamic hormones, that's for posterior pituitary. And then the pathology involving the pituitary gland is the pituitary adenoma. There are also so many pathologies which affects the pituitary gland, but this one is one of the most commonest that affects the pituitary gland. So in the slide of the pituitary gland, you most likely see this, the anterior pituitary, which is the pars distalis, and it is well stained because it contains numerous cells. And then the posterior pituitary, which doesn't stain as much because it contains more unmyelinated nerve fibers, so it doesn't stain. And then in between the nerve fibers, you'll see some supporting cells called pituicytes. So the hormones majorly secreted by the posterior pituitary includes the oxytocin and the vasopressin, while the hormones secreted by the anterior pituitary includes the TSH, which is a thyroid stimulating hormone, the growth hormone, the cortical adrenocorticotropic hormone, the prolactin, and which other one? And the gonadotropins, FSH and LH. So gonadotropins. So let's look at other images. So this is the pituitary gland. So you can see the pars distalis, which is the anterior pituitary that stains very well. And then clearly distinct is the posterior pituitary, which doesn't stain well. And then a thin layer in between them, which is not very distinct, and it represents the pars intermedia that stains poorly. So this is a sharp demarcation. That's how you note the pituitary gland. There is a sharp demarcation between the anterior and the posterior. And then most times you see a kind of stalk connected to a kind of stalk, pituitary stalk. Now, the same thing, you can appreciate the image here. You can see a well and uniformly staining area, and then a sharp, poor staining demarcation that doesn't take up the stain, and then a lighter staining area. So this is how you note the pituitary gland. The anterior pituitary contains chromophores and chromophobes, and the chromophores include cells that stain. They stain well. And the chromophores are further divided into acidophores and basophores. So the basophores appear more bluish because they take up the basic stain, while their cytoplasm contains granules that stains bluish, while the acidophores, their cytoplasm stains pink. So that's the reason why the anterior pituitary has this kind of varied cell appearance, just as you can see here. You can see some bluish staining areas with some pinkish staining areas. You can appreciate that. Some pink staining areas within blue staining areas, and then you can see the sharp demarcation that doesn't take up much stain, and then you can see the posterior pituitary that doesn't stain well. So the slide of the pituitary gland is pretty much easy to identify. So development, rat case pouch or hypophyseal pouch, and then location is the cellular tussica. Okay, so that's it for the pituitary gland. Now let's go to the next one, the pineal gland. So the pineal gland, it's not majorly tested in exams, but then we'll still discuss briefly about it. So the idea of the pineal gland, okay, that's how you answer it. They ask you to identify, answer pineal gland. So the reasons for identifying the pineal gland includes the presence of corporal aranesia. So they are also called pineal concretions, and these like aggregation of minerals and calcium salts. So the older the person gets, the more numerous these dark staining irregular masses, the more they appear. So they are called the pineal concretions, and they are small in size, and their sizes varies. So sometimes they can call it the brain sand. Okay, then the next reason for identifying the pineal gland is the presence of pinealocytes or the pineal rosettes. So the pinealocytes are the major cells found in the pineal gland, and they majorly secrete melatonin. So melatonin, so these numerous and uniformly scattered cells represents the pinealocytes that secretes the melatonin that controls sleep in humans, sleep-wake cycle in humans. So the function of the pineal gland is for secretion of melatonin, which takes part in the circadian rhythm regulation. The location is the roof of the third ventricle. Now these are other images of the pineal gland. This, you can see the cells, then you can see the pineal concretions. Same thing here. Brain sand, it's called the brain sand. The pineal gland also contains supporting cells called the glial cells, but then they are not as much numerous as the pinealocytes. So the pinealocytes includes these ones. Then the pineal concretions, these deep staining structures suspended within the abundant pinealocytes. So same thing here. So that's it for the pineal gland. Now, the next organ that we're going to talk about is the adrenal or the suprarenal gland. So the side note, the reasons for identifying the adrenal glands includes 1. Presence of zona glomerulosa. So this zona glomerulosa is just under the capsule. So the zona glomerulosa is just underneath the capsule. So this is the capsule, this is the outer capsule. Then see this zona glomerulosa. Then the presence of zona fasciculata, which are parietal cords of secretory cells with patent sinuses. So zona fasciculata is the much abundant area of the cortex. Then the reticular zone, which is just above and closest to the medulla, which is this. And then the functions includes zona glomerulosa. Zona glomerulosa produces the mineralocorticoids, which is aldosterone. Zona fasciculata produces glucocorticoids, which is cortisol. And then zona reticularis produces majorly sex hormones, which are androgens. The medulla produces adrenaline and noradrenaline. Then the development of the adrenal gland. The cortex develops from mesoderm, while the medulla develops from neural crest cells. So while looking at the slide of the adrenal gland, it appears very distinct because the gland is made up of two layers, the cortex and the medulla. And how you differentiate the cortex from the medulla is that if you come to the medulla, the cells of the medulla are much loosely arranged. They are not as uniform, they are irregular, and then you can find numerous blood vessels or sinusoids within the medulla. So look at these spaces in between the cells. So they are much loosely arranged, and then you can find blood vessels or sinusoids, which are like fenestrated capillaries, but with much wider spaces between the capillaries. So this is due to the high flow of blood in the medulla. So the medulla produces adrenaline and noradrenaline. Then if you come to the medulla, you will also observe demarcation into 3 distinct zones. So this is the inner zone or the zona reticularis, which contains cells that are aligned in different directions and looks like a network, though it's not really prominent here. Then zona fasciculata. This zone stains slightly, and then it contains cells that are more like arranged in columns or in straight columns. So the cells are arranged in straight columns like this. So most of the cells. So from the name, it can give you a clue of the arrangement. Zona fasciculata. Then zona reticularis, which is more like a reticular network. Zona fasciculata, more like bundles, straight bundles. Then zona glomerulosa, which contains cells arranged in like circular clumps. So from the name, glomerulosa, just like the glomerulus in the kidneys. So they are arranged in more circular clumps. So look at the distinct layers, the way the layers are demarcated based on staining ability. So the zona glomerulosa and the zona fasciculata stains better than the zona glomerulosa and the zona reticularis stains more than the zona fasciculata. You can appreciate the distinct demarcation. And then you can also appreciate the distinct demarcation between the cortex and the medulla. So the adrenal gland is very easy to identify in histology. So look at this as well. Look at the clear cortex and then the zona glomerulosa. which contains cells arranged in circular clumps. Then the zona fasciculata, which contains cells arranged in more linear fashion. Then zona reticularis, which contains cells which are much loose and then arranged in different directions. So the cortex, the medulla is not really visible here, but then you can still appreciate the transition from one zone to another, from this zone to this zone to this zone. So this doesn't look like the anterior, like the pituitary gland, because in the pituitary gland, you see the two zones of the pituitary gland separated by a clear demarcation of a poorly developed pars intermedia, which represents the pars intermedia. So you can't find the same thing here. You will just find a clean transition from one zone to another, with the inner zone being larger, with the middle zone being larger than the outer and the inner zone. Unlike in the pituitary gland, that you see the inner zone, which is the pars intermedia, being thin and rudimentary, thinner than the anterior pituitary and the posterior pituitary. But then in the adrenal gland, the zona fasciculata, which is in between the zona glomerulosa and the zona reticularis, is much bigger, and it stains poorly. Doesn't stain as much. Now look at this one as well. This is the capsule, which is a fibrous connective tissue. Then this is the zona glomerulosa. This is the zona fasciculata. Notice the kind of much linear arrangement. Looks much linear around this part, though it's not very visible. Looks like much linear arrangement. And then the zona reticularis, with cells. This part is much loosely organized, with cells running in different directions. And then the distinct medulla. Okay, this is another section of the adrenal gland. You can notice the medulla, the sinusoids within it, these spaces, and then you can notice the capsule, and then you can notice the three distinct zones, with the middle zone of the medulla, with the middle zone of the cortex being larger than the outer and the middle and the inner zone of the cortex. So the middle zone of the cortex is much larger than the outer zone of the cortex and the inner zone of the cortex. See the difference in staining? Same thing here. The capsule, the zona glomerulosa, the zona fasciculata, and then the zona reticularis. So this is the cortex. So this is the cortex. This, okay, it's labeled here. This is the cortex, the medulla. So notice how loosely organized the medulla looks, with sinusoids. This is the cortex, the capsule. This is the zona glomerulosa, not the capsule. This is zona glomerulosa. So this is the capsule. The capsule doesn't stain well because it's connective tissue. It doesn't contain many cells. This is the zona glomerulosa, then the zona fasciculata, which is much numerous and much bigger in size than the other zones of the cortex, and then the zona reticularis, then the medulla. So that's it for the adrenal gland. So this is where we stop for the endocrine organs. Drop your comments and questions in the comment section. In the next video, we'll look at the histology of the nervous system. Thanks for watching.